So first, what is hyperconjugation? We said it is a partial overlap of pi orbitals with adjacent sigma orbitals. Now, pi orbitals, as we all know, is basically present in a double or a triple bond. But in the case of hyperconjugation, we are just interested in the double bond to form extended orbitals. So one of the ways in which question can be asked here is the partial overlap of pi orbital with adjacent sigma orbitals to form extended orbitals is dash. The answer is what? Hyperconjugation. All right. Now, it is also known as no bond resonance. What are the compounds that exhibit hyperconjugations? Now, basically, I would have just said that is alkenes or dienes or trienes. Now, I said compounds containing at least one double bond. If it contains one double bond, we call this kind of compounds alkenes. If it contains two, we call it diene. If it contains three, we call it triene. Meaning that once a compound contains a double bond, there's a possibility of that guy exhibiting hyperconjugation. And the next one is benzene-containing compounds. Right? The benzene ring contains three double bonds that is alternating each other. Right? So three of them, these two compounds can exhibit hyperconjugation. And straight to the point, now, what are the various questions, the possible questions from hyperconjugation? The first one is calculation of hyperconjugable hydrogens. That's one of the ways question can be asked. Number two is indetermination of stability of alkenes carbocation. Please, lest I forget, the compounds that exhibit hyperconjugation, right? In addition to these two guys, we can also have carbocation, can also have radicals. But the major reason why I hardly talk about this number 3 and number 4 is because the scheme of your work, like your scheme, does not really cover for carbocation and for radicals. It only covers for this and this. So that's why I have to skip this other guy. All right. So having given us this, the next thing I'm going to do now, right? We're going to take the question, the possible ways question could be asked. Like I said, if you go to your past questions, mostly likely going to be seeing how many hyperconjugable hydrogens are present in so and so compound. Calculate or determine the number of hyperconjugable hydrogens. So that is what we're going to be doing for the first one. All right. Now, one of the ways, another way in which question can be asked is application of hyperconjugation. One of the applications of hyperconjugation is determination of stability of alkenes, stability of carbocations, and stability of radicals. Right? Perhaps you've heard something like primary carbocation, secondary, and tertiary. The reason why tertiary carbocation is more stable than secondary is because of hyperconjugation. Right? So let's look at how questions can be asked. Now, we want to see how we can solve for hyperconjugable hydrogens in a double bonded compound. Remember I said compounds that exhibit hyperconjugation is compound that have at least one double bond and also a benzene ring. So the first one we have number one, or the steps. Let's look at the steps. Steps involved. Number one is identify the carbons of the double bond. Now, identify the carbon of the double bonds. In some cases, the double bond might just have one double bond, which involves two carbons, right? Number two, you can say circle them. Number two, asterisk the carbons directly attached. to the carbons. Asterisk the carbons directly attached to the carbons of the double bond. Number three, count the hydrogens on the asterisk carbon. The hydrogens becomes the hyperconjugable hydrogens. All right, so this is basically the three rules. Once you get these three rules, bam, any of the questions you see, you apply it, and then we are done. So I'm going to keep this one side of the board. I'll give us 2 or 3 questions here to actually ascertain this. Now, it's very important for me to state this, that if they are giving you guys questions, the question could come in form of, they can give you the name of the compound, which you have to first of all use the name and get the structure before you can now start, checking out all of this. Or you might be very lucky, they'll just give you the structure at once. So whichever of them, as the case may be, just do the needful, right? So let's look at some few problems. All right. Determine the hyperconjugable hydrogen in this. Is one of the ways question can be asked. There are just two ways. The first one is either they'll give you the structures, and then you're asked for the number of hyperconjugable hydrogens, or they'll give you the name, and you're asked to give the number of hyperconjugable hydrogen. In a case where the name is given to you, all you just have to do is to use your knowledge of organic chemistry, interpret the name to the structure, and then adopt these 3 steps. So I'm just going to leave this side so that I'm going to leave both of them here. So I'll just be reading out the steps and then be answering the question. Now imagine you actually open your past questions or you go inside exams or they say, how many hyperconjugable hydrogen are in this compound? The first thing you're going to do is identify the carbons of the double bond. There are cases where we can have more than one double bond. I gave us one double bond here, 2 here, and 3 here. Right? So come here. The 2 carbons of the double bond is just these 2 guys. This and this. These are the 2 carbons of the double bond. So you've identified them. The next one is asterisk the carbons directly attached to the carbons of the double bond. Asterisk the carbons directly attached to the carbons of the double bond. Now this is a carbon of the double bond. All right. The carbon directly attached to this guy is this, 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 and this. I'm done asterisking those guys. The next thing I'm going to say, count the hydrogens on the asterisk carbon. The hydrogens become the hyperconjugable hydrogen. So here, this carbon has this carbon here has 2 hydrogen. This 3 is not counted for this carbon. So we have 3 here, 2 here, 3 here, 3 here, and 2 here. 2 plus 3 is what? 5. Plus 2 is what? 7. Plus 3 is how many? So here we have 10 hyperconjugable what? Hydrogens. Now, in the case of some compounds like this, which I doubt they may not want to give you something like this, but just in case they decide to play a smart one, tell them you're smarter. Now, the 2 carbons of the double bond, there is a carbon here and there is a carbon here. So you circle this guy or you put it. There's a double bond, there's a double bond. Here, there's a carbon here, there's a carbon here. All right, so the carbons directly attached to the carbons of the double bond. Right, we're going to asterisk those carbons. Those carbons, their hydrogens will now be the hyperconjugable hydrogens. So you can see the methyl group that I just asterisked, and of course you can see the 2 carbons of the ring that I asterisked. Those points are carbons. They are asterisked because they are directly attached to a double bonded carbons, and as such, their hydrogens will exhibit hyperconjugations. All right. So now the number of hydrogens on each of those carbons of the ring is 2. Right, we have 2 carbons on the ring, so each of them will have 2 hydrogens. So 2 hydrogen times 2 is going to be 4. Okay, so 2 here, 2 here. So 2 plus 2 is 4, plus 3 is going to be 7. Now, in this next compound now, we have a compound with a benzene ring. Now, it's important for us to know that all the carbons of benzene are double bonded carbons. All right, so since they are double bonded carbons, we are going to look forward to the carbons that are directly attached to those carbons of benzenes.
All right, so we're going to asterisk the carbons directly attached to those carbons and then count the number of hydrogens on them. So as you can see, 2 plus 3 is 5 hyperconjugable hydrogens. All right, in this next example, we want to look at how we can solve these particular questions. Remember I said they can give us at times the name of the compound and then you're asked to give the number of hyperconjugable hydrogens. So we're going to interpret the name of this compound to the structure and of course, you know, get to find out the number of hyperconjugable hydrogens. Now the steps is already written on the board, so we're going to start up immediately. Okay, first we're going to interpret the name, starting with the parent name, but2-ene. But means 4 carbons, so we're going to write out the 4 carbons. Now we're going to number the carbons, preferably from the right? So you number the carbon 1, 2, 3, and 4. Now they said 2-ene, so you're going to put the "-ene" at carbon number 2. And of course, you can see that we have 2,3-dimethyl, which means 2 methyl group, one on carbon 2 and the other one on carbon 3. So we're going to come write the first one on carbon 2 and of course write the second guy at carbon 3. Okay, so the next thing you're going to do is to add hydrogen to carbon 4 and carbon 1 so as to complete the structure. So we're going to have 3 hydrogens on carbon 4 since it has 1 bond. Same thing will be applicable to carbon 1. Now, the next thing we're going to do here is to actually circle out the 2 carbons of the double bonds. After which we're going to asterisk the carbons directly attached to the carbons of the double bond. So as you can see, we have 4 carbons directly attached to the 2 carbons of the double bonds. And after which we count the hydrogens. We have 3 hydrogens each on them. So you can see 3 in 4 places. That is 12 hyperconjugable hydrogens that is present in that compound. We have application of hyperconjugation in the stability of alkenes. Okay, now if I have 2 compounds, 2 alkenes compound, the one that is more stable or the one that will be more stable is the one that has the more number of hyperconjugable hydrogens. So the higher the number of hyperconjugable hydrogens, the more stable the alkenes would be. So we want to check this using these 2 alkenes, but2-ene and but1-ene. Okay, so the first one is but2-ene and the second compound is but1-ene. All right, so the first thing you're going to do is to actually circle out the 2 carbons of the double bond, which you can see the first but2-ene has 2 carbons directly attached to the carbons of the double bond. So the hydrogen there is 3 plus 3, that is 6. So that one has 6 hyperconjugable hydrogens. And the second compound, which is but1-ene, if you circle out the 2 carbons of the double bond, the carbon directly attached to that is just 1 with 2 hydrogens attached to it. So the but1-ene will have 2 hydrogens attached. So between but2-ene and but1-ene, but2-ene would be more stable because it has more number of hyperconjugable hydrogens.